Have you ever wondered how a small red stick wrapped in paper can blast apart solid rock? In movies, dynamite is often shown as an unstable explosive with a burning fuse and a dramatic countdown before a massive blast. It's become one of the most recognizable symbols of destruction in pop culture. But the real story is far more fascinating. Dynamite isn't just about explosions. It's an invention that transformed construction, mining, and history. So how does dynamite actually work? Let's dive right into it, right here on History of Simple Things. To understand dynamite, we first need to look at the explosive at its core, nitroglycerin. Despite its name, it has nothing to do with the glycerin used in soaps or cosmetics. It's a chemical compound made by treating glycerol with nitric and sulfuric acids, creating a pale, oily liquid packed with chemical energy. The problem is that nitroglycerin is extremely unstable. Even a small shock or temperature change can trigger an explosion. In the mid-1800s, frequent accidents made it too dangerous to transport safely. The turning point came with Swedish chemist Alfred Nobel. After deadly accidents involving nitroglycerin, including one that killed his younger brother Emil, he set out to make it safer without sacrificing its power. In 1867, he discovered that mixing nitroglycerin with diatomaceous earth, or kieselguhr, turned it into a moldable paste. It could then be shaped into paper-wrapped sticks for safer transport and use. Nobel named it dynamite from the Greek word dynamis, meaning power. So why did adding a dirt-like powder make nitroglycerin safer? The answer lies in physics, not chemistry. Diatomaceous earth doesn't react with the nitroglycerin. It simply absorbs it like a sponge, preventing the liquid from moving around. The explosive keeps the same power but becomes far less sensitive to bumps and vibrations because it's trapped within millions of tiny pores. Even then, dynamite doesn't explode simply because someone lights the fuse, a common movie myth. The fuse burns until it reaches a small device called a blasting cap, which contains a much more sensitive explosive. When the cap detonates, it creates a powerful shock wave that sets off the dynamite. Without that sudden impact, a stick of dynamite will usually burn instead of explode. When the blasting cap triggers the dynamite, a rapid chemical reaction occurs in a fraction of a second. The nitroglycerin molecules break apart, forming hot gases such as nitrogen, carbon dioxide, and water vapor. These gases expand to thousands of times their original volume while reaching temperatures of several thousand degrees Celsius. The key to dynamite's effectiveness isn't just heat, it's speed. Unlike ordinary fires, dynamite undergoes detonation, where the chemical reaction travels faster than the speed of sound within the explosive itself. This creates an intense pressure wave that delivers enormous force almost instantly. Depending on the formulation, the detonation wave can travel at around 7,000 meters, 22,000 feet per second, more than 20 times the speed of sound in air. Interestingly, dynamite isn't the most powerful explosive. Although it's famous, modern explosives like ANFO, TNT, RDX, PETN, and HMX are often more powerful or better suited for specific uses. ANFO in particular became the mining industry's preferred explosive because it's cheaper, easier to produce, and safer to handle in large quantities. Even so, dynamite remained widely used for decades thanks to its reliable balance of power, portability, and safety. Another common myth is that old dynamite becomes weaker over time. In reality, it can become even more dangerous. As it ages, nitroglycerin can separate from the absorbent material and leak out in a process called sweating, leaving highly sensitive droplets on the surface. This makes old dynamite extremely unstable, which is why it requires specialized handling and disposal by explosive experts. Although dynamite is often linked to destruction, its greatest impact has been in building the modern world. It made it possible to carve railways through mountains, dig tunnels, construct dams, open mines, and build roads across difficult terrain. By allowing workers to remove rock in hours instead of weeks, dynamite helped drive massive engineering projects and reshape the modern landscape. Alfred Nobel had mixed feelings about his invention. While he believed safer explosives could benefit construction and mining, he knew they could also be used in war. After reading an erroneous obituary that called him the Merchant of Death, he became concerned about how history would remember him. Much of his fortune was later used to establish the Nobel Prizes, honoring achievements in science, literature, and peace. So, how does dynamite actually work? It stores an enormous amount of chemical energy in a relatively stable form until it's triggered. A blasting cap creates a powerful shock that causes the nitroglycerin to rapidly break down into superheated gases. As those gases expand almost instantly, they generate a shock wave capable of releasing tremendous force. It's not just a bigger version of fire. It's a precisely controlled chemical reaction that transformed engineering and helped shape the modern world.
Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.